Okay, so let me continue with the solution of the example that we are trying to solve. So this is the location of our load. So this is ZL dash. Also, we need to draw a rotated circle. As I'm not drawing an exact circle, so the actual readings that you will get for this example may not be accurate, but once you understand this whole method, then with the help of a compass and scale, you will be able to solve it in the exact manner, okay? So I have tried to draw a circle that I was calling as rotated. So this is lambda by 8 rotated 1 plus jx. So now, because we are designing shunt double impedance matching circuit, so if you remember, I mentioned that we need to convert or transform ZL into Y dash. And this can be easily done by drawing a line which will connect this ZL with the center, okay? And then with almost equal distance on the other side, we will come somewhere over here. Okay, somewhere over here. So this point, this is now going to be YL dash. So ZL dash, which was equal to 1.2 minus J 1.6. When you transform it to YL dash, so what is the value of YL dash? You can see that it is on this circle 0.4. So the real part or the conductance part is zero point 0.4. And the imaginary part is, let me take the value which is close to the actual one. It is almost 0.3. This is point. Now, what is the circuit that we are trying to solve? Shunt circuit that look like this. So now we have while dash. Stub number one is connected at this point. So this is our stub number one. And we will be finding out L1. And of course, what we need to do is we need to find out what is D1. Similarly, at a fixed distance of lambda by it. There will be stub number 2, and we will find out L2. But of course, once we know B2, then we will find out L2. So this is, now look at this point that we are, if I am standing at this point, before connecting stub, at this point, how much is the admittance? While dash having this value. And what is the location of this value on the Smith chart? The location of this value on Smith chart is this one, okay? Before connecting the stub. Now, when you will connect the stub, so what this stub will do? This stub will provide only B1, which means this part. So the real part will not change when you connect stub number 1. What will change? Imaginary part will change. So real part will remain constant, and imaginary part, which is susceptance, will change when you will connect a stub. Now, we don't know B1 right at this stage, but what is the purpose of this circle that I have drawn? This is the circle that will help us to find out B1. So we will say that let's move on this circle. So let me use a different color. Okay. So what I will do is I will say that this point is now its real part will not change. So it means it will have to move on this resistive circle with a 0.4. So if you use this and then you move on this 0.4 circle, again, this is the point, this is the circle that I'm moving, and you find out that where you will touch this rotated circle. So you can see I stop somewhere over here where I will cross this circle. You can see that I am moving in such a way that resistive part 0.4 is not changing, but imaginary part is changing. And what is changing the imaginary part? I am assuming that I have connected this stub number 1 and it will provide me some B. And my goal is that this stub should provide me this much susceptance so that this point, which was originally at this point, it moves to this point. Okay. Now, how much? We need to find out how much is the value of this point. Okay. So you know the real resistive part is still 0.4. So what is the resistive part? 0.4. But imaginary part, we need to read how much is the imaginary part. Okay. Because I'm explaining with respect to this particular figure, which where I haven't drawn an exact circle. So with respect to that, you can clearly see that the imaginary part of this point is this one, which is 1.8. So how much is the imaginary part? It is 1.8. So we started with this point, with this much value. And now I am at this point where the value is this much. So you can clearly see that as I mentioned before, resistive part is constant. Imaginary part has changed. How much imaginary part has changed? It has changed from 0.3 to 1.8. It has changed from 0.3 to 1.8. So it means how much should be B1? So 1.8 minus 0.3, it becomes 1.5. If you draw this circle exactly, and then also you need to take this exact distance, then the exact value, just to keep thing in perspective, the exact value of B1 is 1.3. Okay. But don't need to be confused with actual exact. You only need to understand how I get this value. What is the method that you are using? Okay. So now you have found, so this is our solution, and this is going to be your solution number 1. So as I always mentioned, there are always 2 solutions for any impedance matching circuit. So we have been able to find B1. Okay. Now I will find L1. I can find, if I want to find L1, I can find, but it's better that first we find B2 and then we will find out L1 and L2. Okay. Now, how to find out B2? So what I have done now so far, what we have done, we have transformed the load impedance into load admittance. We have included the effect of stub number one, and now B1 is added to YL dash, and we are sitting right over there. Now you can see, in order to reach to stub number two, so this is our stub number two position, we have to travel a distance equal to lambda by 8 towards generate. So if I want to move from this point to this point, I have to travel a distance equal to lambda by 8 towards generate. And you people already know that towards generator means that I have to move clockwise direction on Smith chart. Now lambda by 8 distance, how to travel this much distance, that is also important point. So there are, again, you can use whatever method you like, but the simple method that you can use is you need to draw an SWR circle. Okay, now what you will do, you will open your compass such that its center is this one. And how much you will open it? You need to open it with this much radius, with this much radius. Okay, and then you need to draw a circle, SWR circle. So again, I am drawing a rough circle. So when you are drawing a circle, you will, it will look like this. Okay, but you don't need to draw a complete circle. What you will need to do is you need to stop where this circle that you are drawing, it cuts the 1 plus jx circle. Okay, so let me draw this and then you will see why I am stopping at this point. So I will stop at this point. You can clearly see why I have stopped at this point, because this, when I'm drawing a circle, I was drawing a circle and I stop at this point because at this point I am crossing this circle. Which circle? 1 plus jx circle. So automatically what I have done is I have traveled a distance that is equal to lambda by 8. So let me draw this line so that you can get the idea. If you measure this distance, so we started from this point, and where I've stopped, I stop at this point. So this distance is always equal to lambda by 8. This is one method. Other method that you can use is you started at this point. Okay, so first of all you need to find out where is your location. You are using wavelength towards generator scale, so you need to find out what is this point. So if I use this one, it is almost 0.17, but let me call it x1. So right now you are at this point. So how much distance I have to travel? I have to travel a distance of lambda by 8. So whatever reading you get from this, add lambda by 8 to that. And you will get a new reading that I call as x2. And then you need to find out where is this x2 on this scale. And you will find out that this will be x2, this one. So you will mark that point, and then you will draw a line from center to this. So again, you will be at this point. So no matter which method you like, you will always end up at the same point. So now we have traveled a distance of lambda I8, and now we are standing at the position of stub number 2. We are now at position of stub number 2. We haven't connected stub number 2, but we are at the position of stub. But we know that when we connect stub number 2, it will provide B2, and right now we don't know what is B2. Okay, but now we know that once we are at this point, so we need to find out what is the value of this point, because it is 1 plus jx circle. So we know that the real part is 1. All we need to do is to find out what is the imaginary part of this point. So with respect to the figure that I have drawn, this imaginary value must be this one. It's almost, this is 2, this is 2.2, 2.4, 2.6. So with respect to my rough calculation, this is 1, it is 2.6. So I will write 2.6. Now, what is my goal? Where I want to be so that circuit is matched. And as I mentioned many times, I want to be at the center. And right now I am at this point. So what should happen so that this point comes to the center? Center is 1. And right now I am having a value of 1 minus j 2.6. So what should happen? I should have plus j 2.6 so that this cancel out and this point moves to the center. So now this gives me an idea that B2, how much stub number 2 should provide so that circuit becomes matched. It has to provide plus 2.6. Again, let me write down the actual value as well so that when you practice it, you should have the idea. This actual value is 3.3, okay? So now you can see that using graphical method, what we have done is our load was mismatched. It was at this point. And using stub number 1 and stub number 2, we have brought this point to the center. And as we know, whenever you are at the center, it means the circuit is matched. Now, what is remaining? We still need to find out L1 and L2. We know that stub number 1 should provide this much susceptance. Or if you draw exact circle and exact scale line, then we know that stub number 1 should provide me 1.3 and stub number 2 should provide me 3.3. So how I will get this exact 1.3 and 3.3? With the help of stub, I need to adjust the length of the stub, because susceptance or reactance provided by any stub, it depends on its length. So as we have been asked to design a stub using open circuit, so both of these stubs are open circuit. So let me first of all solve this. Again, I will use the actual value, okay, 1.3. So what is my expectations from stub number 1? Stub number 1 should provide me how much susceptance? 1.3. And it is open circuit. So first of all, you need to identify where is the open circuit point on the Smith chart, because this is admittance. In case of impedance, we know that this is the open circuit point and this is the short circuit point in impedance mode. But as always happen, impedance when it becomes admittance, it is shifted by 180 degrees. So this is the open circuit point in impedance mode. So when it is shifted by 180 degree, it means this is the open circuit point. So I will call this point as Y open circuit. And this becomes Y short circuit. So with respect to admittance, On admittance Smith chart, this is the short circuit point and this is the open circuit point. Because we are dealing with open circuit, so this is going to be our reference. Okay. Now, you assume that you are standing at this point. Okay. You are at this point from circuit point of view, and from Smith chart point of view, you are standing over there. And now you need to find L1, so it means you will be going in this direction. So this is L1 equal to 0. And then as you move and you reach to this point, so this L1 is increasing. And because you are moving towards the generator, so we will be using this scale. So I will start from this point, and where I will stop, where I get this value, which value 1.3. So what you need to do is you need to keep looking at this scale reading, this one. Okay. And you need to stop wherever you get 1.3. So 1.3 is over there. Okay. So when you move, you will be stopping at this point. So let me draw this. So where I will stop at this point because I get the reading of 1.3. So this movement, I started from this point and I stop at this point. So you just need to connect the center with this point. So 1.3 on this one, so this one. And then you measure how much distance you have traveled. So this is of course 0, and then you are increasing, and you can clearly see that this is almost 1.14, 0.142, 0.145, 0.145, or 0.146. This is the reading. So how much is L1? 0.146 lambda. So when L1 is adjusted to be equal to 0.146 lambda, it should provide us this much reference. In a similar manner, now you can do this for L2 as well. How much is the required susceptance from B2? Again, this was rough calculation. The actual is 3.3. So again, open circuit point. You started at this point, and then you will be moving until you get which reading? You get B2 equal to 3.3. So 3.3 is it may be somewhere over here. So this is let's say 2. This is 3. So somewhere here you will get 3. So in this case, you will move up to this point. So you started at this point, and then you will stop somewhere where you will get the reading of 3.3 somewhere. So it's almost, if you read this reading, wavelength word is 0.206. So 0.204 or 6 lambda. So now our solution number 1 is complete. Now how to find the second solution? So let me okay, so let me talk about solution number 2. Okay, procedure is almost similar. Okay, let's find out what is how you can easily find out solution number 2. So now we need to find out B1. So I will call it B1 dash. and then L1 dash, B2 dash, and L2. So going back to the start, how we started solving this problem, we first of all located ZL dash, which was equal to 1.2 minus J 1.6. And because we were asked to design a shunt matching circuit, so what we did, we transformed ZL dash to YL dash, and we arrive at this point. And I also roughly find out that this YL dash is equal to zero point 0.4 plus J 0.3, because if you locate this, this is 0.4, and if you locate this, this is almost 0.3. In the first solution, my goal was that how to move this point so that we are on this rotated circle that I have drawn. So in the first solution, I moved in this direction and I arrived at this point. And then using this, I found B1 to be equal to 1.5, or the actual value is 0.1. In second solution, you can move in the opposite direction. You can move, let's say I'm moving on this circle, okay, the same point. But now I'm moving in the opposite direction, and again I will stop at the point at which I cross this circle. So I will stop at this point. So this was our original point, while dash. Previously I moved to this point, and now I move to this point. So now I need to find out how much the value has changed, or in other words, what is this point? So again, this point, because real part is not changing, so real part is still 0.4, but imaginary part has changed, and we need to find out how much is it has changed. It was 0.3 previously, and now you need to read this reading. This one is 0.1, so now this is, let's say, 0.1. So while dash, which was 0.4 plus J 0.3, it has now become 0.4 plus J 0.1. So it means this imaginary part has decreased from 0.3, it has become 0.1. So from this, we can find out that B1 dash must be negative 0.2. So 0.3 minus 0.2 will give you this value. So it means step number 1 in second solution should provide us this much susceptance, minus 0.2. Let me also write down the actual value, because my circle was not exact. So there is some error in that. So actual value that you will get is minus 0.114. But if you understand the procedure, it will not make any difference. This is how we find. So B1 dash is no. Now, if you want, you can still find L1 dash. So let me find L1 dash so that you understand the same prep process. So again, open circuit stub. So we'll start at this point, and then I will move until I get to this reading. So because I'm moving in the clockwise direction, so we know that all of these readings are positive. So it means I will keep on moving. From this point, I will keep on moving. I will complete this half circle almost. Once I move to this point, now the values are negative. Okay, so you need to find out where is this negative value. Okay, so negative values, of course, यहाँ पे अगर आप देखें, यहाँ तक आप जाएंगे, सारी negative values हैं. यहाँ पे आपको minus point something यहाँ पे मिल जाएगा. यहाँ पे अगर आप देखें, तो यहाँ पे आप जाके रुक जाएंगे. So ये जो आपने distance travel किया है, आपने ये measure करना होगा. कौन से स्केल के ऊपर? वेवलेंथ टू ऑरिजिनेटर स्केल. सो हमने 0 से स्टार्ट लिया है, यहाँ आप जाके रुक गए हैं, तो यहाँ पे जो रीडिंग होगी वो आपने नोट करनी होगी. तो ये तकरीबन आपके पास आएगा 0.482 लैम्डा. 0.428 लैम्डा. सिमिलरली B2 डैश आप कैसे फाइंड करेंगे? P2 डैश के लिए अगेन हमें क्या करना है, हमने स्टब नंबर 1 से स्टब नंबर 2 की तरफ जाना है, तो हमने कितना डिस्टेंस कवर करना है, लैम्डा बाय 8। तो स्टब नंबर 1 से स्टब नंबर 2 तक जाने के लिए हमें कितना डिस्टेंस ट्रेवल करना है, लैम्डा बाय 8। सो अगेन हम सेम प्रोसीजर यूज करेंगे। इस वक्त हम यहाँ पे एक तरीका तो ये है कि आप इस पॉइंट को मार्क करें कि इसकी वैल्यू क्या है, इस वक्त आप किस जगह पे खड़े हैं। सो मैं इसको मार्क कर लेता हूँ। एक तरीका क्या होगा कि आप इसको इस तरह लाइन ड्रॉ करेंगे। सो इस वक्त हम यहाँ पे, तो आपने क्या करना होगा, हाँ, इस पॉइंट को, इस वेवलेंथ टुवर्ड जनरेटर स्केल पे इस रीडिंग को आप नोट कर लेंगे। इसको मैं x1 कह देता हूँ। और इसमें फिर आप देखेंगे कि इसको हमने यहाँ से हमने आगे कितना जाना है, इसमें लैम्डा बाय 8 ऐड कर दें, और ये जो वैल्यू आ जाएगी इसको मैं x2 कह देता हूँ। तो वेवलेंथ टुवर्ड जनरेटर स्केल पे आप देखेंगे ये x2 कहाँ पे है, वो जहाँ पे है उसको आप मार्क कर देंगे और फिर सेंटर को इससे मिलाएंगे। तो जहाँ पे वो लाइन इस 1 + j एक सर्कल को क्रॉस कर रही होगी वहां पे आप रुक जाएंगे। ठीक हो गया। दूसरा तरीका क्या है, ये तो एक तरीका है। दूसरा तरीका आप ये कर सकते हैं कि आप SWR सर्कल बनाएं। SWR सर्कल कैसे बनाएंगे, आप यहाँ पे आप कंपास का एक एंड रखेंगे और उसको कितना ओपन कर देंगे, इतना ओपन कर देंगे। ठीक है। सो दिस शुड बी द रेडियस ऑफ योर SWR सर्कल। ठीक हो गया। और फिर इस सर्कल को आप SWR सर्कल बनाते हुए कहाँ पे आपने इसको रोकना है, मैं इसको लेट्स से मैं थोड़ा सा इरेज कर देता हूँ। यस, ये आपका S1 + J एक सर्कल है। ठीक है, मैं इसको थोड़ा सा नोटेट कर लेता हूँ ताकि इसके पर्सपेक्टिव से हम इसको डिस्कस करें। ये सर्कल है जो कि पहले से बना हुआ है, जिसको हम 1 + J एक सर्कल कहते हैं। ये आपके पास है 1 + J एक सर्कल। सो आप जो SWR सर्कल बनाएंगे इस रेडियस के साथ, ये जब आप बना रहे होंगे जहां पे आपको ये क्रॉस करे, किसको क्रॉस करे, 1 + J, यहाँ पे आपने रुक जाना है, क्योंकि ये जो एक्चुअली यहाँ से लेकर यहाँ तक जो डिस्टेंस होगा ये एक्चुअली लैम्डा बाय 8 के बराबर होगा। तो जो मैं आपको पहले कह रहा था कि x1 ये रीडिंग नोट करें, इसमें लैम्डा बाय 8 करें तो x2 आएगा, तो एक्चुअली ये वैल्यू आपके पास x2 आएगी। तो पिछला मेथड जो मैं आपको बता रहा था, जब ये पॉइंट आप मार्क कर लेंगे और फिर सेंटर से मिलाएंगे तो आप देखेंगे कि ये इसको यहाँ पे कट करेगा। तो यहाँ पे आप जो रुक जाएंगे ये आपके पास अब आपकी वो वैल्यू है। अगर आप देखें अब हम एक ऐसी जगह पे आ गए हैं, इस पॉइंट को मैं मार्क कर रहा हूँ, इसकी जो रियल है वैल्यू है तो 1 हो गई है, क्योंकि हम इस सर्कल के ऊपर है। हमने ये देखना है कि इसकी इमेजिनरी वैल्यू क्या है। तो अगर मैं इस फिगर के हिसाब से देखूं तो ये है 1.4। तो आप लिखेंगे 1 + J 1.4। तो हम स्टेप नंबर 2 की पोजीशन पे आ गए हैं और उस जगह पे हमें कितनी एडमिटेंस मिल रही है, 1 + J 1.4। लेकिन मेरा गोल ये है कि मैंने सेंटर तक पहुंचना है। तो अब सेंटर तक पहुंचने के लिए क्या करना होगा, इसको कैंसिल आउट करना है। इसका मतलब क्या हुआ कि अब हम कह सकते हैं कि B2 को हमें कितना रखना पड़ेगा, B2 को हमें रखना पड़ेगा -1.4। तो B2 स्टब नंबर 2 इतनी ससेप्टेंस प्रोवाइड करेगा, तो इसका इफेक्ट क्या होगा कि ये पॉइंट जो है यहाँ से मूव करके कहाँ पे आ जाएगा, सेंटर पे, विच वॉज अवर डेस्टिनेशन। तो इस केस में अब L2 कितना होगा, L2 अगेन आप उसी तरीके से फाइंड करेंगे। ओपन सर्किट स्टब है, यहाँ से आप स्टार्ट लेंगे और फिर आपने कहाँ तक, किस जगह पे आपने पहुंचना है जहां पे आपको इतनी ससेप्टेंस मिले। तो यहाँ पे अगर आप देखें ये वो जगह है, ये आपको नजर आ रहा है -1.4। तो इस पॉइंट तक पहुंचने के लिए हमें कितना डिस्टेंस कवर करना पड़ेगा, ये पूरा डिस्टेंस कवर करते करते यहाँ तक हमें आना पड़ेगा। और फिर ये रीडिंग आप नोट कर लेंगे कि ये वेवलेंथ टुवर्ड जनरेटर स्केल पे ये रीडिंग कितनी है। तो ये अगर आप इसको प्रॉब्लम को सॉल्व करेंगे तो ये तकरीबन आपके पास आती है 0.350 लैम्डा आती है। सो आपने सोल्यूशन 2 भी इस तरीके से फाइंड कर लिया। So this is the complete explanation of double stub matching circuit. या आप कह सकते हैं कि मैंने आपको स्टेप बाय स्टेप इसका सारा वो बता दिया. Any question? I think it's enough for today. Maybe I will take one or two lectures more. तो वो मैं देख लूंगा कि या तो मैं lectures record कर दूंगा और उसको upload कर दूंगा, ठीक है. और अगर again कोई question आपका है तो Google Classroom आपके पास available है. You can post your question or any confusion that you have. You can comment on the Google Classroom and I will try to answer your question. Any question so that I can continue. Okay, before I ये एक चीज मुझसे मिस हो गई है. मैं आपके साथ जी अटेंडेंस लिंक मैंने शेयर नहीं किया था. सो अटेंडेंस लिंक मैंने चैट विंडो में शेयर कर दिया है. तो आप लोग अपनी अटेंडेंस आज के लेक्चर की मार्क कर दें. Thank you very much. See you next time.